Till now we have discussed about the strengths and weaknesses and major motivations for the broadband wireless access technology. Now, let us start with the characteristics of the WiMAX technology. WiMAX is a broadband technology because it does provide the throughput on the order of 135 Mbps. So, it allows multiple broad frequency ranges. It has direct LOS and as well as NLOS. So, if a 75 Mbps is available on both links, it can support image, video and data. So, if you go to the triple play service, video, audio and data, it is sufficient to carry all the traffic. 100 megahertz per operator is required for see again we are talking about the various generations. So, I have given here 3 generation 1G, 2G, 3G, but now we are talking about 4G. In case of 4G, we expect that the standard must support multimedia applications, and for multimedia applications bandwidth requirement is higher, quite higher. In case of WiMAX, but here there is a question, why do not we give much bandwidth through the service providers at the existing band? Like GSM, they are asking for more bandwidth so that they can accommodate more users. CDMA players like Reliance is providing the cellular service in CDMA. So, they are also asking for more bandwidth, but government is not giving or is not fair as far as they state. The problem is that at lower band the entire band is already crowded. So, where from you will give the bandwidth? If you go at higher band in the spectrum, you know that spectrum starts from 0 hertz, which is DC, up to 10 to power 28 hertz. In between somewhere we are using 10 gigahertz up to 66 gigahertz, and of course, there are some lower frequencies also which we are using, as I have shown here, for 2 physical layers. So, at this range the spectrum is relatively available, but if you look the cellular services which we are providing at 900 megahertz or 1800 and 1900 megahertz, over there spectrum is already crowded. Secondly, if you allow the operators to use high frequency band, then you take just 2% of the carrier frequency, it will be more. If you take 2% of 1 megahertz, otherwise if you take 2% of 1 gigahertz, the 2% of 1 gigahertz will be 1000 times more. Okay. So, this is how the larger bandwidth can be provided to a single operator, and it will be, there will be 2 advantages of this. The one, that in the same bandwidth he can accommodate more number of users. Secondly, nowadays multimedia applications are bandwidth intensive, isn't it? When I want to do the video conferencing, it means it requires at least minimum bandwidth requirement should be available to him, to the party always. So, that bandwidth can be available only when the service provider has the bandwidth. So, this is here we can give a single operator 100 megahertz bandwidth. In GSM we do provide like 25 megahertz plus 25 megahertz, 100 megahertz per operator. So, he can give all the services which are asked by the user. So, as such it is a suitable technology for 4G. Lower cost, because the chipsets of PCs are available nowadays, base stations, common platforms bring mobility, uninterrupted access, roaming is possible, convergence is also possible. It is spectrally efficient. For all communication engineers, you must know what is spectrum efficiency. The basic idea of spectrum efficiency is that I have one cycle, 1 hertz, how many bits it can transmit per second, that is the spectrum efficiency. So, in this case it can squeeze 3 bits per hertz per second. So, it is spectrally efficient. Is cost effective. Cost is always seen in terms of how much traffic it can carry per hertz. So, it is carrying 3 bits per hertz. So, it is cost effective. Wide coverage, as I told you, up to 50 kilometer it can cover. Harmonization, yes, because nowadays in world there are so many networks. So, if you want to realize the dream of a real global village, then there will be a seamless communication across all access technologies. So, because its name is already interoperability, it means we are designing the system in such a way that all the different patches of networks can be harmonized. We can it will be transparent to the user, irrespective of what is the underlying technology. User can access the information anywhere, irrespective of the underlying technology. Public key infrastructure authentications are there, highly scalable network, viability of WiMAX as an alternative to 3G. You can compare it with UMTS, WCDMA and evolution data only. Their market penetration is not so encouraging till date. If you read some newspapers or IEEE papers, you will find that yes, they are available to some extent, but the technology has not been accepted as such. So, WiMAX can be an alternative, can be a viability as an alternative to 3G and higher. You can compare the data speed. WCDMA provides 100 kbps, evolution data 2.4, HSDP 8 to 10, WiMAX even up to several kilometers from this 500 kbps. Coverage area you can compare 50 kilometer, spectrally efficient, interference is quite less. Yes, IP connectivity. See, you all know that the next architecture is all IP based. Circuit switching, message switching, it is going to be over. Everything will be converted into packets, whether it is voice, image or data. So, the backbone is IP based. This technology does support IP connectivity, and whatever is the transport technology, whether it is ATM, IPv4, IPv6, Ethernet or virtual LAN, irrespective of that, at the network layer it deals with packets, and that is why it is so viable as far as next generation networks are concerned. Architecture I have already told you. Cost of development is cheaper, backhaul connection to cellular services. Standardization is again an advantage because multiple vendor solutions are coming in the market. Economies of scale, mass production. If there are so many vendors, then mass production will reduce the prices. Research and development, yes, there are so many industries working on this in collaboration with the universities. This is SWOT analysis. See, this is interesting. I will take few minutes here. SWOT, you know that it deals with strength, weakness and opportunity. If there is a question which technology will survive the market, so you can compare these three technologies. Wireless, and I told you a lot, because wireless LAN is the most widely deployed technology. So, I need to compare 3G again is a cellular standard and then WiMAX. You will find that in wireless a high capacity under large bandwidth, but coverage is small. It has the opportunity that supplementary access methods can be used, like I have told you that 802.11n can provide up to 540 Mbps. So, there are some access methods which can improve the data transfer rate, but it is getting threats from 3G and ADSL. 3G networks, yes, they have the strength in terms of data and speech under high mobility environment, high capacity, but their weakness is that bandwidth is small. And market, yes, market demand is there for the variety of services, and they are being designed to meet the requirements of anywhere, anytime connectivity. But again, it is getting the threat from wireless LAN, VoIP and WiMAX. Finally, WiMAX, it does provide the large coverage, does provide the high capacity, unified standards, but it is immature because it is still under evolution and people are working on this. Interoperability is possible that you can work upon. Threats are from ADSL, cable fiber and others. Well, let me give the brief account of the typical areas of application. Initially, I told you that nowadays demand is from rural areas. So, you explore the technology which can meet the requirement of rural area. Even our previous president APJ Kalam, he was very fond of the technologies which can be used by the common people rather than the people sitting in air conditioned room. So, saying you explore the technology which a common people, a rural village can use. This technology is very viable as far as rural areas are concerned, because in rural areas nobody would like to lay down the OFC. OFC is good enough when number of users are large, so that they can earn the revenue. If there are 2 or 3 users in a village, nobody would like to lay down the network. WiMAX does provide a solution for such type of environments. I will give you one slide over that. In addition to that, small and medium businesses, a hotspot backhaul it can provide, mobile devices it can be connected to, it can be used for interconnecting base stations. IPTV also, if somebody is using TV, then for IPTV means here the TV content is delivered in terms of IP. First one was SDTV, standard definition TV, then came high definition TV, the third TV is IPTV, internet protocol TV. For IPTV, WiMAX is the most suitable technology. So, you can explore this area. Access network I want to show here. The idea is that how this technology can be used for providing the connectivity to rural areas. Say, let us say at some place you have the GPRS network. I have taken the GPRS network because it can provide the data service. GSM does not provide the data service, so GPRS. GPRS has two interfaces, BTS and BSC. These are the parts of the tower. Okay. After the tower, I have used a subscriber station. Here I told you that in WiMAX, it can have the maximum range up to 50 kilometer. So, in villages, the number of users are less and they are far apart. So, let us say in a particular village there is a residence of Pradhan. So, at Pradhan's residence you need the internet connectivity somehow. So, you have one user. In the nearby village you can have one more point. So, we can have one subscriber stations in this village on another subscriber station at other place, and of course, you need to connect to the backbone also. So, you can connect to the backbone because one subscriber station can cover up to 50 kilometer and so. So, as such you do not need to put so many stations, a few stations will be sufficient to cover the large area. So, here the advantage is that you can have a very large area as far as WiMAX is concerned. So, this is how the WiMAX can be a very useful technology for providing the connectivity to the rural areas. No other technology can provide this. Evolution, there are various standards of the WiMAX technologies. The first is 802.16, it is used for fixed users. Then nowadays we are moving towards 802.16D, 802.16E, which is providing the mobile connectivity also. This is 802.16, this is for mobile WiMAX and it was released in September 2005. Current state of the art, there are so many patents available, 330. I mean to say that the work is going on. Even Motorola has come up with Y4, Fujitsu has also come up with a product. In Indian context, there are certain cities which are rigged up on WiMAX. Pune is having WiMAX. Even in Haryana, BSNL is planning to have 10 cities on WiMAX. This is a pilot project and let us see how much they are successful, because it has certain problems with mobility till date. So, they want to lay down the network and see what are the problems. So, BSNL is doing some similarly MTNL is going in Delhi and Mumbai. This 802. Is another broadband access technology which was released in 2002. It does provide the mobility support up to 250 kilometer. We can compare 802.20 with 802.16. The advantage of 802.20 is very high speed, vehicular like trains and all those, 250 kilometer per hour. But in that case, the bandwidth will not be so much high. 802. This is again wireless regional area network. Next generation satellite networks, they are also covered under broadband wireless access technologies. HAP is again lower orbit satellite communication system which can give the connectivity to the rural areas. But ultimately the result is that the future network will be a combination of WiMAX and Wi-Fi. We need to integrate the architecture as well as quality of service mechanism. Which technology is better? You can always compare in terms of the ubiquitous nature, data rate and mobility support. Here is I have prepared the slide that if you increase the coverage, the data transfer speed will come down. If you increase the data transfer speed, then coverage will be less. So, you have to make a compromise, what do you want. WiMAX is cheaper. In order to conclude, most promising technology for broadband wireless access over the metro. It can handle digital IP media, so it can be a viable solution for 4G, key enabling technology for 4G. Challenges are full mobility. It is a research problem that in order to provide the handover from one terminal, one substation to another substation, you need the handover mechanism, interoperability, test specifications being evolved. Frequency band, see when I say that the lower 10 gigahertz frequencies can also be used, but those frequencies are already allocated by the government to others. So, if you want to use those frequencies, then reallocation has to be done. So, this is just again a political decision that government has to take. Short term limitations, still we do not know who will be the service provider. BSNL is being the government body, so it can go ahead with that, but other private players, we do not know how the license will be given to those. Availability of equipments, yes, there are some equipments like PCMCIA cards which can fit into the laptop, but still they are in trial stage, and we expect that those will be available in 2007 and next 2018 market in full swing. Solution to this, of course, will shape the future development, and surely once the WiMAX is available, the wireless world of 4 zones we shall be living in. We are moving towards the mobile information society once all these concepts could be realized technically, and we can say that we shall be living in the wireless world. That is all from my side. Now it is open for discussion.